have the function x to the third minus 4x to the second, and we want to find the critical numbers and then also the points at which f has a maximum or a minimum. And so this is what the graph looks like. And this point right here, we call this the and we said that f, the function f, has a relative minimum at this point. And then we said that the function f has a relative maximum at this point. And so we want to find these points right here, the points where the function f has a relative maximum and a relative minimum. And the reason we call them relative maximum, relative minimum, because this is not the highest point on the graph. The graph has no highest point because it goes up infinitely up. And then same thing here, the graph will go infinitely down, and therefore it doesn't have a minimum. But this right here, this is called relative minimum. And so to find the critical numbers so that we can determine these local relative maximum and minimum. And so first find the derivative, and then set the derivative equal to 0. And so the derivative of x to the third is 3x to the second, and then this is 4 times the derivative of x squared is 2x. And so we get 3x squared and minus 8x. And the next, set the derivative equal to 0. So we have this right here. This is the derivative. This is equal to 0. And then solve for x. If possible. And so to solve this problem right here for x, we have a common factor x, so we can factor it out. So it'll be x times 3x minus 8 equal to 0. So this means that x is equal to 0, or 3x minus 8 is equal to 0. And so right here, solving for x, we can add a to both sides and then divide by 3. And so x will be a thirds. And so we have two critical numbers. So critical numbers, x equal to 0 and x equal to a thirds. And then what we want to do is evaluate the function here at x equal to 0. And so f 0. And then we just replace x with 0. And so this is equal to 0. So what this means is that when x is 0, y is 0. And then if we look at the graph, we see that at the point 0, 0, we have what's called a relative maximum. So this function here, the function f of x, has a relative maximum at the point 0, 0. And then now we'll do the same thing for the other critical number, which is the 8/3. And so if we replace this with 8/3, and so we have 8/3. And we use the scientific calculator and simplify this. This comes out to be negative 256 over 27, or approximately negative 9.48. And if we look at the graph right here, and we will go from here to here, that's negative 10. So that's about negative 948. And so we say that this function right here has a relative minimum at the point 8/3. And negative 256 divided by 27. And once again, we call this a relative minimum because the graph does not have a minimum. Because the graph here will go down forever. And then this is a relative maximum. So we say that the function has a relative maximum at this point and a relative minimum at this point. And the function does not have a maximum or a minimum. Since the graph goes up infinitely, so no maximum, and graph goes down infinitely, so no minimum.